Hi you guys, today we'll be talking about polynomial functions in Unit 5. Okay, and polynomial functions are a continuation of quadratic functions in that now we're going to be dealing with degrees of higher numbers. Okay, and so what I'm going to do is I'm going to lead you guys through what we're talking about. So polynomials and polynomial functions are going to be defined first. Okay, so a polynomial is just basically something with more than 3 terms, or more than 2 terms, I guess you could say. So it could be 2x to the 5th minus 7x squared plus 3x minus 2. So that could be a polynomial. Okay, a binomial is one that has 2 terms, so binomial could be 2x minus 3 or 5x to the 3rd minus x. That would be a binomial. Now monomial would just be one term, so like 3x to the 2nd or 5x to the 5th or negative 3x, just plain old 3x, negative 3x. Okay, so a polynomial is one that has 4 or more terms. Now, a polynomial function is something you can actually have a relation with, okay, or something that has a relationship with the y variable. So, in other words, you could graph it and you would actually get a regular form. Okay, now standard form of a polynomial function is hugely important because that's just how everyone writes it and everything, okay? So usually it starts out with ax to the n plus bx to the n minus 1 plus cx to the n minus 2, and so on and so on and so on until you get down to the last letter, let's say w or plus wx to the 0. Okay, and that equals y. So that's your standard form of a function. And so what you want to do is you want to have the highest exponent come first, then the next highest, and then the next one below it, down until you get to what is called the constant. Okay, so that's standard form. I just realized that line looks pretty freaky deaky. So let's get a good one that looks good. Let's make... Okay, so that's hugely important right there. Okay, so we just defined monomial, so there we go. All right, now degree of a polynomial. So let's take this one right here. Okay, now degree right here. Let's do nice colors. Let's do blue. Okay, a degree of a monomial and a degree of a polynomial, they're both pretty much going to be the same. They're the same idea. Okay, so degree is the highest exponent in the expression. Okay, so let's take, there's a polynomial up there. Let's do 3x to the 4th right here. Okay, so the degree right here is equal to 5. Okay, and the degree right here is equal to 4. Okay, it's the highest exponent. It doesn't matter if the number is positive or negative. Doesn't matter about a whole bunch of stuff except for that exponent. Now the degree is important because you can actually do several things. You can tell how many real answers it's going to have. You can tell how many turning points it's going to have in the graph. And back in the day before graphing calculators, this was huge stuff that you had to remember. Okay, so it just helped out with everything. Okay, end behavior and turning points. So let's go to let's come up with a kind of graph. Okay, so end behavior and turning points. All right, there's 4 different situations that could happen for end behavior. Now end behavior is just what happens when x goes to positive infinity or x goes to negative infinity. What's happening at the end of the graphs, because we always draw a portion that's around the quadrant and stuff. So first off, if you graph your type of graph and you get something that looks like this, okay, these are turning points right here. Turning point 1, turning point 2, and turning point 3. So in other words, instead of going up, you go down. Instead of going down, you go up. It's another type of direction that you can go with. Okay, so turning point's pretty easy to identify. All right, now as for the idea, okay, let's go copy. As for the idea with the end behavior, now let's put it right here, paste, there we go. Okay, the only thing you need to know is you need to look at this, and you need to look at the degree. You need to look at the sign. You need to look at the sign in the front, and you need to look at the degree, and you can tell the end behavior. Okay, so all right, if a is positive, and we use a is greater than 0, and n is even, okay, then your end behavior is going to look like this. It's going to be going up to the right and up to the left. Okay, I don't know what's happening in the middle. You need to actually work with some other stuff, and I'll show you some other stuff that works that way. Okay? All right, now, if a is not positive, in other words, it's negative, and n is even, okay, in other words, it's going to be flipped upside down. So in other words, it's going to go down and to the left and down and to the right. Okay, so something pretty simple. All right. Now, what if a is positive, but n is odd? Okay, so in other words, it's an odd number, 1, 3, 5, 7, 9, whatever. Okay, if it's positive, if the first number is positive, and it looks like this, it's going to be going up and to the right and down to the left. It's going to be kind of like a disco. Okay, and if a is not positive, but n is odd, it's going to be just the reverse of that, obviously, because it just flipped right upside down. Okay? All right. So that's the ideas behind what's going on here with this stuff. Please understand, if you do need to get into standard form, you may need to do some distribution and just work it out. Like, for example, this is the correct way of standard form. And that's it for pretty much for talking about polynomial functions, and we'll be learning how to solve them a little bit later. Thank you. Bye.